Something impossible unfolded in our sky while the world slept. In less than half a day, an interstellar object we had tracked for months grew from a handful of kilometers to something that could no longer be called small. One morning, it was a compact wanderer. By nightfall, it had become an engineered colossus. Measurements from before and after are shocking. Where 3I Atlas once spanned roughly 3.9 kilometers, cameras recorded a new outline at 8.1 kilometers. The numbers themselves break the rules we rely on to understand reality. Publicly, the updates were cautious and sterile. Privately, there were urgent calls, canceled trajectories, and the kind of classified meetings reserved for the scenarios that intelligence agencies train for, but hope never arrive. What happened to 3IATLAS in those hours was not growth in the natural sense, it was assembly. It was the deliberate folding of structure into form, under energies and protocols that do not exist in any human catalog. Telescopes across the globe registered a cascade of emissions unlike anything previously logged. Infrared surges so intense that sensor arrays registered after images imprinted on detectors. Optical systems designed to probe the faintest galaxies were overwhelmed by a focused blaze emanating from a single object inside our own solar system. Equipment from the Atacama to Mauna Kea had to be powered down to avoid damage. The burst lasted precisely 39 minutes and 12 seconds, according to synchronized observatory clocks. When it ended, the silhouette of 3IATLAS no longer resembled an icy fragment. It resembled architecture, not jagged, random accretion, not chaotic debris fields. Symmetry and repetition, angles and modules, all assembled with a mathematical rigor that suggested design rather than chance. Close analysis revealed a stepwise transformation. The change came in clear stages, each with a defining purpose. Stage 1 looked like a recasting of the core. For the first 2 hours of the event, the interior of 3I Atlas became a furnace. Temperatures spiked into the thousands of degrees Celsius. Yet rather than vaporize, the inner regions reorganized into crystalline lattices, far stronger and more complex than anything we build. Material we assumed fragile was reconstituted into load-bearing frameworks with densities that defied expectations. Stage 2 was outward construction. Over the next several hours, scaffolding extended from the core in repeating geometric arrays. Hexagons tessellated into planes that folded into three-dimensional trusses. Tubular appendages rolled out in precise sequences, each following ratios and constants known from pure mathematics rather than geology. Stage 3 was system fusion. The final phase linked the new modules with conduits, nodes, and articulated joints. The whole became more than the sum of its parts. Networks of channels and cabling opened between sections and began exchanging energy and data in pattern-rich transmissions recorded by radio telescopes. The emissions were not noise. They were protocols. They were ordered sequences of frequencies with redundancy and error correction. The signature of deliberate communication rather than random natural discharge. Researchers at multiple facilities compared spectrograms and agreed that the transmissions displayed temporal patterns that matched engineered control systems. A radio astronomer at a major observatory likened what they saw to construction crews coordinating heavy lifts, but on a scale and with a precision that left human engineering dwarfed. The energy involved raises questions that cross into the metaphysical. The power required to rearrange mass, to forge new structural elements from raw material in hours rather than eons, should have been visible across interstellar distances. Yet 3I Atlas had been quiescent until the moment the operation started. Where did the power come from? Some models propose vacuum energy extraction, a process only theoretical in our physics texts. Others hypothesize tapping of higher dimensional reservoirs, or the use of directed energy beamed across light years. The most unsettling interpretation is that the power arrived from an external source. Analysis of timing and phase coherence suggests incoming beams delivering energy with unbelievable focus and negligible dispersion. If that is true, then 3I Atlas is not an isolated artifact. It is part of a system. It is a node in an infrastructure designed and maintained by an intelligence with capabilities far beyond our own. The geometry of the newly formed structures is itself instructive. Fibonacci spirals twist into antenna-like arrays. Fractal lattices repeat at scales from meters to kilometers. Helical coils and nested polygons appear tuned for field generation and reception, not for aesthetics. Each pattern appears to perform a physical role. Hexagonal grids provide optimal stiffness for minimal material. Spiral geometries concentrate and steer fields. Fractal branching multiplies surface area for signal coupling. These are not decorative choices. They are engineering solutions optimized across scales. While construction progressed, 3IATLAS was not. Radio observatories recorded layered transmissions on multiple bands. The signals contained synchronized bursts, handshakes, and confirmation packets, analogous to data exchange. More disquieting still, replies were received. Signals returned from objects previously cataloged as inert rocks and minor bodies. What we thought were random asteroids lit up in coordination, acknowledging status updates and aligning their own emissions into the broader network. It became clear the expansion was not autonomous. Instructions were being relayed and executed. Timing analysis shows commands, arriving with pauses far too short to be explained by simple light travel time from the nearest astronomical sources. The coordination implies either predictive control algorithms that compensate for delay, or a control network whose nodes are positioned such that latency is negligible. Both possibilities undermine our understanding of what spatially distributed engineering can look like. Imaging of the expanded sections revealed compartments the size and proportions of living spaces. Pressurized cavities with interior geometries, scaled for occupants, approximately 3 meters tall, appeared in multiple modules. Environmental controls and atmospheric management systems were visible in thermal maps, maintaining gas mixtures not compatible with human physiology, but consistent across compartments. Docking interfaces appeared, their dimensions indicating vehicles far larger than the original object. In some places, interior volumes seemed larger than their external shells suggested, as if volume and surface geometry were being manipulated in ways that bend classical intuition. Structural supports carry loads through mechanisms we cannot identify, and materials show behavior inconsistent with known metallurgy or ceramics. Fabrication zones were apparent. Areas with concentration gradients of raw material intake, processing chambers, and automated assembly lines emerged as the expansion progressed. The machinery is arranged for continuous production. Assembly robots or their analogs would be capable of creating complex components at rates and tolerances that suggest industrial scale output. But what would be manufactured and why? The parts observed to be emerging are not copies of human devices. They are different, yet they obey the same universal physics that governs wave propagation and mechanical stability. Their design logic matches the larger infrastructure. Theories about their purpose include resource acquisition, local manufacturing for supporting presence, or construction of auxiliary assets for deployment across the system. Military and defense analysts monitoring the data fear a suite of mission profiles none of which are reassuring. One scenario visualizes systematic harvesting of raw materials across the solar system. Mining nodes could be deployed to asteroids and moons, returning refined matter to hubs like 3IATLAS for fabrication and shipment. Another considers observation and cataloging on an unprecedented scale, the arrays providing continuous high-fidelity surveillance of planetary surfaces and emissions. A third contemplates strategic logistics, the object acting as a staging area for distributed operations across inter-system space. The response from human institutions has been measured but intense behind the scenes. Classified contingency documents indicate that spacefaring agencies have rehearsed for contact scenarios where the encountered technology is not merely different, but orders of magnitude more capable. The policy in those documents is cautious. Observe. Avoid interference. Because if what is out there can marshal energies and coordinate across interstellar distances, any attempt at confrontation risks accelerating actions we do not understand. Assets were repositioned for constant monitoring. Deep space arrays were tasked to track all electromagnetic bands for coordinated activity. Military assets began repositioning satellites and recalibrating sensors. Private companies with space infrastructure quietly initiated contingency protocols. Public statements remained minimal, couched in scientific terms and appeals to patience. That lack of transparency is intentional. There are doctrines about managing panic and preserving operational flexibility. The reality is that the science does not offer reassurance. Power generation at the observed levels with such efficiency suggests technologies we do not possess. The precision of directed energy transference challenges the limits of known field manipulation. The communication protocols are integrated through hardware designs that repeat the same mathematical signatures across modules, like a language using geometry as grammar. What is most unnerving is that this event may not be the first instance of its kind. The sophistication and repeatability implied by the design point to a technology refined over countless cycles. Somewhere in other systems, similar transformations may have played out. Civilizations might have watched their local architectures appear and their resources reallocated before they could intervene. We could be observing an established method of interstellar engineering applied here, because this solar system offered advantages in material or position. As days pass, the expansion continues. Current measurements indicate incremental but steady growth. The rate is not constant. Spurts of activity correlate with bursts in communications and apparent retooling of fabrication zones. New launch platforms and deployment chutes are forming along the outer rims. Energy throughput continues to climb, without any detectable fuel consumption or waste streams that fit our models. The arrays grow more capable, increasing bandwidth and range as they incorporate more fractal elements and longer conduits. If unchecked, projections show 3I Atlas, reaching tens of kilometers within months and altering its mission profile as its manufacturing capacity scales. At those sizes, the presence will no longer be merely an astronomical curiosity. It will be a Dominion-scale infrastructure with the potential to shape or consume regional resources on a scale that redefines strategic balance. The central question remains unresolved. Is 3I Atlas a neutral surveyor expanding to sustain presence and gather knowledge? Is it an extractor building supply lines to harvest matter for a distant economy? Is it an emissary of a civilization that views star systems as raw material for projects beyond our comprehension? Each possibility carries consequences dramatic enough to demand sober planning. What we do know is this: The age when humanity could assume primacy within our local space has ended. A new actor has appeared on the stage with tools and intentions we cannot read with certainty. The prudent path for now is relentless observation, rigorous analysis, and clear thinking about contingency. We must prepare for many outcomes while resisting the temptation to assume hostile intent without evidence. Still, the visuals are undeniable. Structures continue to sprout, manufacturing lines hum into existence, and docking bays yaw like the mouths of giant factories. The expansion that began in a single night was not an anomaly. It is the first visible breath of an engineered presence taking root. What follows will determine whether humanity remains a footnote or becomes part of a broader operational network that spans much more of the cosmos. Subscribe to stay informed as we track every observable change and bring analysis from scientists, engineers, and former insiders who are watching this transformation with the same mixture of awe and dread. The object known as 3IATLAS doubled while we slept. What it will become will decide the fate of our skies and perhaps of us all.